Professor Murali Ramanathan. She works in the area of bug detection.
Software engineering.
Software engineering, to be precise. Okay. And we look forward to your talk. Make sure that you ask a lot of questions and make the speaker.
If you don't ask me questions, I will ask you questions, and then you'll be forced to answer. So. Okay, so let's start with the talk. Before that, how many of you have ever coded in Java language or are aware of, okay, good number. And how many of you are aware of data structures like list, arrays, okay, good. Okay, so let's get it started. The title of the topic is test generation to detect loop inefficiencies. Any guesses what this talk is about? What is an inefficient loop? Just raise your hands and answer the questions. They are very simple questions. All of you know the answer. Just raise your hands. Okay. It's okay. What can be the other example? Inefficient loop. Yeah, but if the program is terminating, then in that case, is there any example where loop is inefficient? Correct. So basically it is performing some operation which can be done faster, or maybe it is doing some computation which are not used anywhere in the program, right? It's quite possible. Have you seen any programs where it is computing something in the loop, for example, average or sum, and then it is not used anywhere in the program, right? You can just get rid of such loops. So let's get it started. I have a very simple problem for you. I have two bags. And in first bag A there are red balls, and in bag B there are blue balls. I have numbered these balls, and my problem is find the balls with matching numbers from bag A and bag B. Very simple question, right? So what's the answer to this question? Very good. So you followed some algorithm in your mind. You had some procedure, like, right? You are looking through two bags. So can any one of you explain what were you doing? What algorithm did you follow to come up with the answer? Okay, so for every ball in bag A, you are traversing through all the balls in bag B, right? So let's quickly go through the algorithm that you suggested. So we are picking up one ball from bag A, then we picked up first ball from bag B, and then we check if they are equal, we will increment the counter, right? So to start with, our output is 0, and now we'll go on doing this. So we pick up the second ball from bag B, which is 2, it is not equal, output remains 0. Then we'll pick up the third ball, output is 1, so the ball matches, so I just incremented the counter. It's very simple algorithm. And then I just iterated through all the balls in bag B. What happens after that is I pick up the second ball from bag A, which is numbered 23rd, and then I'll start iterating over bag B once again, right? So it's 7 and the output remains 1. So this is going to happen for every ball in bag A. Do you see a problem with this approach? Okay. It's of order n square, correct. So the approach A's complexity that approach A that she suggested, it has big of n square complexity. So what was the problem? We were repeatedly iterating through all the balls in bag B, right? So is there a better approach? Yeah. Okay, but what is the complexity of sorting? Okay, better than this approach. Okay. Okay. Cool. Correct. Correct, you'll just check at the index. Any other approaches? Any other? Okay, fine. So let's go with her approach now. So we have another approach where we change the container of elements in B. So the way she suggested, you will convert it into an array, right? Okay, so what I did is I tried to convert this bag B into array B. So array B has, suppose the balls in bag B are ranging from 1 to 13 or say 1 to 12. So I just have an array with 12 size, and I'm going to put these balls into the array. So what I'm going to do is 7th ball will go into the 7th index, and similarly I just populated all the balls in the array. Now the way she said, just pick up first ball from bag A, check if the ball is present at the index, and then just set the counter, right? Pretty easy. 23 is not there, so output remains 1. Like that, the complexity is reduced to big O of n, right? Okay, so approach B's complexity is is far less than big O of n square, because it also involves the complexity to convert the bag from to the array, right? Okay, now is there even better approach? Oh, okay, before that, what is the problem with this approach? Correct. So how can you resolve it? Correct. You can use a hash set. There contains to check if the element is present is a big O of 1 complexity, and the problem is pretty simple now. So increased space complexity can be handled by using hash set instead of array or list. Okay, so what was I talking about till now? It is all about software efficiency. We want fast softwares. If we are loading some application and if it is just loading, we don't want to wait forever. We'll just close the application and we'll go for some other alternative. It's very obvious, right? So no one wants a slow or inefficient software. It causes economic loss, or it might frustrate end users. So there are certain kinds of bugs. You might have come across assertion failures or stack overflow, null pointer exception like bugs. There are some different category of bugs which are called as performance bugs. It's easy to guess that they are related to performance, and it is affecting the performance of the application, right? So it's basically implementation mistakes done by developer that causes inefficiency in the program. Performance problems are hard to detect during testing and manifest in the field. Any guesses why is it difficult to detect performance problem in advance? If I give you an application and if I tell you find out null dereferences in this application, it's very easy, right? You can just run the application in different ways and figure out if there is a null pointer exception. But what will you do about performance? Any guesses? How will you detect performance in advance if you are given an application? Correct. Yeah, so you need to go through different kind of environments if it is hardware related bug, hardware related performance bug, right? So there can be software related performance bug which is a problem in the code. So let's see what it is. Okay, so they degrade application responsiveness and they end up frustrating end users. So we need to fight performance bugs. Why is it required? Because they escape compiler optimization. So we talked about inefficient loop, right? So if it is performing some operation which is not used anywhere, like dead code maybe, then will it be is it possible to catch it using compiler optimization? What kind of compiler optimizations do you know? Correct. So such kind of optimizations can be used. But when it comes to loop, it is not possible to use compiler optimization. Why? Because it is about complete program. It's about all the calculation, and compiler generally optimizes locally, right? So, and the performance bugs are very common in the field. About 50 performance bugs are fixed in Mozilla per month. So, what will we do? We will do testing, because we want applications to be faster all the time, right? So, you know testing, it's a process of executing the program with the intent of finding software bugs. Developers write test cases, then they run it, there are assertion failures, you fix it, and then you run it again. So, okay, so I think most of you are aware with the cycle. Developer will write tests in the beginning, then these tests are run, there are assertion failures or some different kind of errors, then you go and fix the program so that this error don't appear once again, and then you go back to first stage. This is a regression test. You keep on generating tests, running it, finding errors, and then fixing it. So let's look at a very simple example. There is a class linked list. It has two methods. One is empty, which checks if the linked list is empty, and another method called append, which basically adds an element to the linked list. So this is a sample test which is generated. So what is this test doing? It is generating an object or instance of a linked list. It is asserting if the object is empty, right? Assert true, a dot is empty. And now there is an append method, a dot append, which adds one element to it, and then it checks if the list should not be empty after that because you have added one element, and then it checks if the size of the list is 1, right? So such kind of tests are written to ensure that the functionality is correctly implemented. So what do you think this test is checking? It is basically checking if the implementation of append is correct. It is checking if the implementation of isEmpty is correct, right? After adding the element, the size should increase. Now what will happen? Suppose you run this test and this to assertion fails. So what does this mean? Sorry? Okay, but you know that is.empty was correct at first place, correct? So there is more probability of append function being wrong, right? So this is how you localize bugs. This is all in case of functionality bugs, where some functionality is provided in advance, developer implements it, and then you need to test whether he has correctly implemented or not. Okay, so the implementation of append method is most probably buggy. Okay, so how will we detect performance bugs? Let's follow the same cycle as that of the functionality bug. But you don't know how to write tests to detect performance bug. How do you write it? You don't know where the performance is located. There is no expectation out of the performance that it should be, a particular test should run in 10 seconds. There is no specification like that, right? So this is a hard problem. This is a difficult problem. And then, what is a test failure in case of performance bug? If I am giving you a test similar to the test for linked list, how do you know if it is efficient or not? How do you know if there is a better execution for this test, right? You don't know if it can be performed or it can be executed in time lesser than that. So this is a difficult question as well. And then, how do you know if the error is fixed at all? So it's not like assertion failure where assert is failed and then you fix the program and now assert is passing and then you clearly know that the error is fixed. So how do you detect such problems? So this cycle, though there is a proper system involved to detect functionality bugs, the system for performance bugs is not yet evolved. So let's, okay, so when we were going through this, what do you think is required? The main thing that is required is generating tests to detect performance bugs. So writing tests for detecting functionality bugs is pretty easy. It's based on specification. But writing performance tests, meaning tests that will detect performance issue, is very difficult. So it was not evolved, and this is one of the approaches that we suggested to write performance tests. Okay. So let's go over it one by one. So there is a tool which is developed which will take an application as an input, any kind of application, a set of classes, and that will output performance tests. So basically what we are trying to do is, there are some performance blocks in the program. For example, for that matching balls problem, if the developer has implemented approach A, and then we are trying to detect that developer has implemented a bad approach or has implemented a big O of n square complexity approach, we will try to detect it and tell developer that there exists a better way to do it, right? Clear? Should I go ahead? Are you following? Okay. Okay, so let's go through this. Let's try to understand what can be done to generate performance test. So to start with, I'll just take random set of tests. So this is a flow of the tool. It takes some tests. These tests are the unit tests that I showed you in the beginning, some time back. It's going to take this test and do summary generation. That is some kind of summary it is going to compute. And then method summaries will be output of this component. Okay, so let's see how this method summaries look. Okay, so summary generation takes random set of tests as input, and for each method in the program, it is going to record loops present and methods invoked, and that is the summary of each method. So you will, for a particular class as an input, you are going to have lot of tests. So one test that we saw for append method, lot of such tests will be there. You are going to execute those tests and monitor them. Monitor them in the sense you are going to check if there is a loop present in that method, if there is another method invocation from that method, right? Okay, so how does this summary look like? So again, a small example. There is this class called d.java. It has a method foo which takes two parameters, an instance of A and instance of B. It is iterating over elements of A, and then it is invoking a bas function with A and B and ES parameters. So how will the test for this class look like? There is some random test which is creating an instance of A, adding some elements to A, then creating instance of B, and then invoking foo with these instances. So the point is, when I'm executing this test, I'm going to monitor the execution. So you can ignore how it is monitored as of now, but while execution, you can just record that there is a loop. In foo method, there is a loop which is iterating on the first argument, and then from the loop there is a method bars invoked with 2 parameters. So this 2 comma local, here 2 corresponds to the method to the instance B, which is passed as a second parameter, right? And the local corresponds to some local element. So basically here, just for the simplifying the explanation, whatever is not the argument to the method will be considered as local argument. Okay. So you understand, it's very simple summary generation phase where you take a set of classes, you generate some random test inputs, you execute them, you monitor them, and then you have summary in there. Okay, so now method detection phase. So we are taking method summaries as input, and in the end we are giving methods. So these are 2 kinds of methods that I am detecting out of it. One is inefficient method and one is populator method. So let's see what method detection does. So it takes classes under test. So you know what classes you are trying to generate performance tests for. And then you are going to build a call graph with annotated summaries, right? And topologically you are going to traverse the call graph to detect methods with nested loop. Are you aware of topological sort? Okay, good. So let's quickly go over topological sort. You take a set of so update, you have some set in the beginning, you update it with nodes with no incoming edges, right? And then you keep on picking up each one node at a time from that set, and you put it on the output and remove all the outgoing edges. I think most of you know it, right? So for this, what will be the output? Just tell me. You can pick any of them, 3 or 4, 3, 4 and 5. Okay, so up till now we discussed how we come up with the summary of each method, and then we generated a call graph. Are you aware of call graph? How many of you don't know what is call graph? Okay, so basically if you have a method m1 and from m1 you are invoking m2, and suppose you have m3 and from m3 you are again invoking m2, like this, then out of this class or this program you can generate a call graph which tells me what method is invoked from which method. That's all. So this the call graph for this will look like, this is an m1 node, it invokes m2, and there is a m3 node, it invokes m2, right? Simple? Okay. So for example, this we are given a call graph which looks like this. So forget about the summary that I have annotated with each node. So m1 is going to call m2, m1 is going to call m3, m3 calls m4 and m5. Okay, and I have just annotated some summary with this, with each node in this call graph. So can anyone tell me what summary of m1 says? Okay, so the top level method invocation m3 is not happening inside the loop, it is just outside the loop, right? Okay, so pretty simple, we have a call graph and summaries are annotated. Now what is our goal? We are trying to look for the nested loop. We are trying to look for the loop which is not performing any computation or which is being iterated again and again unnecessarily. So in the example at the beginning, we were reiterating over bag B, but we could have avoided that by using a hash set instead of bag B, right? Okay, so that's what we are going to do here. Let's form a connection with this phase of method detection and what we did in the beginning. So with the help of summary, we are trying to locate what are the nested loops in the program. And these nested loops are not static. So we are just trying to figure out nested loops in the program. So what will we do is we will topologically traverse to this call graph and we will take these summaries into consideration to check if there is a nested loop or not, right? So what is the first node? Which one should we consider? We are topologically traversing. So you know topological sort, right? So you start from the node where there are, okay, so we can, so basically we will start with M1, then we can go to M2, M3, M4 and M5, right? But for understanding, I have done it by reverse topological sort. So are you aware of reverse topological sort? Okay, so reverse topological sort is when you don't have any outgoing edges, right? And then you will delete incoming edges for the node. So, so we'll start with, okay, so let's start with M2 per se. So for M2, if I'm just given M2 as a method, is there a possibility of a nested loop execution when I'm invoking M2? No, right? Okay, so we'll just ignore it. What about M4? What about M5? What about M3? Is there a possibility of nested loop execution when this method is invoked? Okay, with what parameters? Yeah, it's a nested loop, but what arguments can be controlled from M3 so that the arguments on which it is iterating is maximum? Do you get my point? So in M3, the loop is iterating on the first parameter. In M4, the loop is iterating on first parameter. Correct. So M3 has a nested loop where outer loop is iterating on the first argument and the inner loop is iterating on the second argument. So we have got a candidate method. So we are just looking for the nested loops as of now. We are not doing anything at all, right? But another point is, what if this loop was iterating on a local parameter? Will we consider it? Correct. So if it is a constant, we cannot control it, right? So even if the loop is inefficient, we cannot show it's inefficient by controlling the argument. Did you get the point? Okay, so suppose there is a method and there is a nested loop inside the method, but the parameter on which it is iterating on is local. That means I am locally creating it and passing to it, right? So it's very difficult to create a test and show that this loop is inefficient, because I cannot control it from outside. It's locally created. I cannot create a test input where I can show this loop is inefficient. So that's why we are just considering loops where the parameters can be controlled. So you get it right. So there is a candidate method M3 with interesting indices, that is 1 and 2, right? Okay, next. So what about M1? Okay, so what are the arguments to be passed to M1? Correct. So what is it? It is 2 and 3, right? Is there any other possibility of okay, so we have a candidate method M1 with indices 2 and 3. Is there any other possibility? Correct. Correct. Yeah, but what are the set of parameters here? Okay. Okay, so you get it, right? So we are just we just created a call graph, and then we are iterating to the call, we are traversing through the call graph and trying to find nested loops in the method, and we are just finding appropriate indices. So what are these indices? It means second and third parameter of M1. For suppose this case, second and third parameter of M1 should be sufficiently large to expose the inefficiency, right? Okay, so let's we have a candidate method already at M3, so we just appended it with M1. Okay, so we figured out what are the candidate methods in the program, right? Which have potential nested loop which can be inefficient. Now next is a populator method detection. So do you So try to understand that we are trying to create a test. We are trying to come up with a test where we are going to invoke this candidate method with sufficiently large collection of inputs, right? So when I said this candidate method has candidate method is M1 with interesting indices 1 and 2. So we are trying to come up with a test that is going to invoke this M1 method, and it is trying to control this first and second parameter which is being iterated on so that it is sufficiently large, right? This part of the students, are you following what I'm saying? Okay. So we need a populator method. Why do you need this? I know that second and third parameter of M1 should be sufficiently large. But to make sure they are sufficiently large, I need to add the elements to the collection, right? So for example, in the linked list case, there was an append method that was increasing the size, or it is ensuring that the collection is increasing, right? So I need to find out such methods so that in the end, the test will use it. It will create sufficiently large collections. So suppose I have this test. Can you suggest me how can I come up with such populator methods? So populator methods are basically populating the collection. They are adding elements to the collection. So any guesses? Given such test, how will I come up with a populator method? So what is a populator method? How is it going to affect the collection? Loud. It is going to add the elements. So what property of the collection is going to change? Size. So what can we do is, for every method invocation, we are going to track the sizes of the current collections. That's all. It's very simple. So what am I going to do is, so for example, at this point, before linked list, what all collections are present? There is no collection. It's the beginning. So I can't track any sizes. Then there is an assert true statement. Before assert true, I know it's an assert, but still we are going to just track all the method invocations. So before assert, I am going to check the size of A, right? It is 0 maybe. After assert, what is the size of A? If it is still 0, it means it is not affecting the collection. It is not updating or modifying the collection. So do you understand? So we are just going to track every method invocation, and whatever collections are present at any moment, we are just going to check if the collection is updated or not. So in this case, what do you think is an populator method? Okay, so append is an populator method because just before append, there is just one collection present in the test, which is A, and the size of A is 0. Right after the invocation, the size becomes 1, right? So do you think there can be other ways of, do you think there are other ways where the size property will change, but it is not actually affecting the collection? Okay, so we just guessed that append is going to add elements to the collection, right? So is there any way where the size will change? We are relying on the size property, right? The size will change, but actually there is no change in the collection. What is the example? Sorry. Yeah, go on. So this size is not the size of A, right? It's the size of collection. It is number of elements present in the collection, right? Do you get the difference? It's okay. So is there any other way where we can affect the size? You get it, right? It's not about the data type. It's about number of elements present in the collection. So what I'm asking is there any possibility that with this approach, we are going to say this is a populator method, but actually it doesn't work like a populator method? Okay, so what's wrong with it?
What we would do is we would restrict the append method to not have duplicates and we keep adding duplicates. So it's not an upgrade recycling.
It depends upon the data structure, right?
Yeah.
So you cannot just generally use this approach. So my question is, we are relying on the property size of a data structure or a collection, is there a way that the size is changing but the collection is not changing? There is no way it can happen. Okay, so there is one such way. So for example, instead of a dot append abc, if I am just setting the size property of a, what if I just say a dot size is equals to 5, or I assign some initial capacity to a? The size is going to change, right? But it's not affecting the collection. Then what will happen in the end when I am generating the test and I am trying to populate this collection? I will be like a dot size. I'll just keep on invoking the size method. Suppose a dot size parameter is 2, parameter is 3. It's actually changing the size, but it is not affecting the number of elements in the collection. So it is called as false positive. So you are detecting some things which are not actually working the way we want them to, right? Okay, so this kind of things can happen. So in the end, the test that we are going to generate, some test will be useless because we don't have exact understanding of whether it is a populator method or not. So there are different sources that will add to this useless test. This is one of them. Okay, is it clear? Okay, so the method append can be used to populate the underlying data structure. Now we have two things, the populator method and inefficient methods, and we are going to give it to a test generator. So test generator is a final component where it is going to take all this information that we collected so far, the summaries that we generated, the call graph, using the call graph traversal, whatever candidate methods we detected, indices we came up with, right? And inefficient methods and populator methods. So there are three simple phases in this component. So we are going to take candidate methods to start with, and then we will create object to invoke the method. So you know, right, if I know there is an M1 method with interesting indices 2 and 3, what is required out of the test? What do we want to do in the test? So we know that M1 has a nested loop with parameters on parameters 2 and 3. How do we ensure that the test invokes M1? What are the phases involved? How will you ensure that M1 is invoked with 2 and 3 as sufficient large collection? Correct. Then? Correct. So, and how will you create sufficiently large collections? Correct. So, basically there are three small steps into it. We create the object to invoke candidate method. Then we pass big collections for interesting indices. Suppose second and third parameters are interesting indices. I don't care about other parameters. Second and third needs to be sufficiently large. That's all, right? And then we create remaining parameters, and then the test exposing inefficient loop is generated. So what is happening? So say there is a candidate method foo with interesting indices 1 and 2, and I'm just showing you a test in the output. Let's try to, I'm not telling you how these objects are generated and all. Let's try to understand if this test makes sense now. So what is happening? Okay, can any one of you decode this for me? So what is happening in this test? Okay. Why is it created? Per se, if foo is invoked on A. Okay. Okay.
There's an object B1 of B is created and B2 is also of B created. Then a loop goes from the argument C. The zeroth, I goes to the zeroth element of that array, and then new object of C is created with size random number, and then B1 is updated to C. After that, again the same loop, and again B2 is updated, and then at the end the foo method is invoked by the A object, and B1 and B2 are the parameter passed, and the last parameter is provided.
Okay, so foo is a candidate method with interesting indices 1 and 2. What does it mean? The first and second parameters should be sufficiently large, right? I don't care about the third argument. So let's just assume that third argument was of parameter boolean, was of type boolean. So I just randomly passed one of the true or false values here. Fine. Now we need an instance to invoke foo and parameters for first and second argument, right? So I just created some instance A for invoking the foo method. And second step is creating big collections of appropriate types for index 1 and 2. So what I am doing here is, I know that the first and the second parameter of foo method, they are of type B, right? So I need to create instances of B first to start with, right? Then I created B1 and B2 such instances, and I know that they need to be sufficiently large. So I'm going to take some random input, say 10,000, and I'm going to update B with B1 and B2 with 10,000 elements, right? So what I'm going to do, how am I going to update? I need a populator method. So for example, in this case, update is a populator method, correct? Update needs a parameter of type C. Okay, now I have to create those many instances of C. And now the constructor of C takes a parameter of type integer. So I have to create the instances in that way, correct? So similarly, I'm just going to create B1 and B2 so that they have, suppose, 10,000 elements in them, and then I'm going to invoke foo. Cool? So what this step is going to do is, so this is a test which I'm going to run on my original version of the program, and suppose it takes X seconds, and then I try to figure out what is the problem with the loop. I'll try to fix the loop, and then I will run the test once again. And then this test is going to run in time much less than X seconds. Do you see the point of using this test? So now so what would have happened if I have an assertion failure kind of test, a test for functionality bug? Assert will fail, we will fix the program, and then we will run the test once again to ensure that the assert is fixed. So in this case, what we are going to do is, we will run the program with this test. It is going to take X milliseconds, suppose. So this execution is going to, this is actually focusing on some particular loop, right? It is saying focus on the loop in foo method which is iterating on first and second argument. So developer is going to look at it and figure out what is the problem happening with that loop, and then he is going to run it once again. And if the time taken is far less than the previous one, then that means the performance bug is fixed. The story is completed. Do you see how performance tests are used?
Ma'am, but in few conditions, suppose I need to solve a problem and that problem needs to be done in SQL. There is no other better solution.
Yeah, then in that case you cannot do anything.
Then how does that?
But this won't detect such kind of issues, right? It is happening only when it is n square. So for example, so in the detection phase, when you are coming up with big of n square, you can actually look at alternate data structure and you can suggest a data structure. So for example, in the beginning problem, the problem was with the data structure, right? So in the method detection phase, I can actually suggest data structures to the developers. I can say, why are you using this data structure? You can actually go for that data structure. It has an efficient method.
So it just basically seems that it would sit less side with other data structures.
Then it will suggest that. Okay. Sorry?
Is it that the object C for class C of the right? Is it visible to only that loop, or will it be visible?
No, it will be visible to only that loop, right? It's a scope. You can reuse it, it doesn't matter. Okay, so I have a question for you. Okay, so this is some method and the parameters are suppose C1 and C2. These are some collections. Okay. Now, so what I'm going to do to create a test for this method? So suppose this is method foo, right? So I'm going to invoke this foo method with some collection C1 and C2. I'm just going to populate it with some random numbers and going to pass to it, right? So now what is my motive? My motive is that this loop should run as long as it can, correct? Now do you see a problem here? Now suppose C1 is having 1, 2, 3 and so many up to many elements in C1, and suppose C2 is having 1. So when I am creating this test, suppose I am passing such kind of parameters to foo method. What will happen? When I am invoking foo with this C1 and C2, it will pick up the first element E in C1. What is this element? 1, right? And it will check if C2 contains E. It is checking if 1 is present in C2. It's present, right? So this loop will immediately break. So even though there is a nested loop available in the method, that I am passing huge collections for C1 and C2, it's still not exposing the inefficiency. Why? Because even though these collections are pretty huge, even though there is a nested loop, the problem is not being exposed because loop is breaking immediately, right? So do you see how can we fix this problem?
While updating V2, what we can do is that we can first check before updating it. If the element which we are using to update V2 is present in V1, then don't update and move forward.
Okay, fine. So what if this program is not contains?
Not contains, then we can just change the condition.
But you don't know what is it, right? You need a generic way to do it. You cannot do it program wise. You need a fixed way to handle all kinds of such programs. Okay, so what we do, so to fix such kind of problems, there are generally patterns involved. So here we are just updating C with random values, right? So what we can do is, we can update it with common elements once. We can update it with distinct elements once. So these are the different patterns that are being created every time, right? So this the tool that we developed, it had 6-7 such different patterns to handle all such things. Now, for example, okay, so one more question. So if I have this collection C1 and C2, you are updating, how do you know what to update it with? So not all the time the type is specified, right? It doesn't happen all the time that I'm saying this collection is of type integer or the collection is of type string. I can just say there is a collection. Then in that case, again the patterns play a major role because you can pass collection of integer ones, you can pass collection of null objects ones, you can pass collection of distinct object ones, right? So yeah, so pretty much that is about the tool. Any questions so far? Any questions? Okay, so let's just quickly go over a small demo. Okay, so I'm just going to show you that this kind of problems, though they are very simple, you may ask me why developers can't understand this at the time of coding. Why can't he just realize that it's a nested loop? Why are you iterating over it again and again? So these problems are very common in the famous libraries that you might be using, like collections. So let's just see one of the example. So okay, this example is very similar to what we discussed. There is a method called retain all at line number 205. So this method, right? So what it is doing is it is taking a collection as an input. It checks if the collection is not null, and if not null, it is iterating over elements of this parameter. So do you understand this code? So anyone from your side, can you please tell me what this code is doing? It's simple, isn't it? You don't follow or you don't want to come forward and answer. Okay, even from this side. Just go through it. What is happening in this method? Do you know what is iterator? It just iterates through the collection, that's all.
then till it has some next element, or till the
Okay, it iterates over all the elements and then it checks if the collection contains this thing, right? And then it does something. So do you see a nested loop here? Okay, do you see a nested loop here? Where is the nested loop?
Checking between E and C, so it checks for every element, it checks if it's there or not.
Okay, so it is checking in collection call, right? So, but the type of, what is the type of call? Yeah, what is the type? So, what all types I can pass to this method? Have you, exactly, it's generic. So, you can pass anything, you can pass array list, you can pass hash set, right? So, it depends upon how the developer is using it. So, if he is using this library, it depends upon, so the efficiency of the code will depend upon how the developer is using it, right? So, if this call is a list, it is for contents method, it is going to iterate over all the elements, correct? Correct, that's what I'm saying. So, if a developer is trying to use this retain all method, and if he is passing a list, suppose, then it's cool, right? Okay, so this is some method from a real world library, and now I want to ensure that no matter how developer uses it, it will be fast. It should be always fast. So what should we do? So this is an API that we are providing. So as a library provider, I want to ensure that it is foolproof, right? I don't want it to go bad when developer is using it in bad way.
we can choose a data structure for which collection.contains has the minimum type.
Correct. So our approach, that whatever we discussed, it will give us an alternative. So this is a very simple example, since collection is in Java, it's part of Java. So one such example can be, what is a data structure that will give you constant time method for, suppose, hash set, right? So this is one method. So this is the original version of the library that was available, and this is a new version. So what are the changes incorporated here are, so I basically check if this collection is instance of set. If it is not instance of set, I'm just going to make sure it is in hash set, right? And then otherwise it is just as it is. So this check is necessary because if it is a hash set to begin with, we are just unnecessarily spending time in changing the hash set to hash set, right? We don't want that to happen. So I have these two versions of programs, and now I will show you how drastic change is there in the execution time. So this is the original. Okay, so I have a test. So using the approach that we discussed, it gave me this output. So I don't think we have time to go over this and understand how is it working. But so this is some test that is output of our approach that we discussed. And then when I run this test on the original version of the library, it is going to take some. So it took 4196 milliseconds, and when I'm running it on the modified version, it just took 50 milliseconds, right? So you can ask, it doesn't really matter from 4000 milliseconds to 50 milliseconds, how does it matter? It's just fraction of second, right? But actually when such kind of computations are happening in practice, in big projects or in big data, if you have heard of, then this might create problems. So that's most of it. Thank you for attending the talk. Any questions?